So what we're doing here at Newt is try to provide water anywhere in the world where water is needed and treat any source water to the quality that's needed for the specific application. So among the different applications we looked at, being able to desalinate water and being able to purify any source water is an important need. And so this technology here can take any source water and treat it to pure water.
This conventional way of using membranes to distill water involves flowing hot, dirty water on one side of the membrane and cold, clean water on the other, and that temperature difference drives the process. And the problem with that is that you have to heat a lot of water, a huge volume of water. All the water you want to purify has to be heated, and that has an enormous energy cost. And so we're using solar photothermal processes which can be very localized, embed them in the membrane and shine light directly on the membrane. That way we don't have to heat all the water at all. We only heat the water that's directly in contact with the membrane. It vaporizes and it condenses on the other side, and we make clean water with we've eliminated the need for heating this very large volume of water.
These membranes we commercially buy, the PVDF membranes, but we coat the nanoparticles in the lab. So initially for coating we were using this method called electrospinning. So in electrospinning you apply really high voltage to the membrane and then you flow this carbon nanoparticle solution on top. So the limitation was that you can only create small membranes with that. So if you want to use it for large scale application, that will not be practical. So we have recently developed a method where we can spray coat these membranes, and that way you can create really large membranes.
So the whole idea behind Newt is to bring nanoscale innovations that come out of nanotechnology, and to bring them into this world of water treatment where the problems are difficult, the technologies may have been around for a while, and they need some real new innovations brought into them to address some very, very difficult and complex problems. And that's really the soul of Newt.
Yeah, I'm a little overwhelmed right now. The verb to whelm. I am a little overwhelmed because I've been looking at YouTube videos on solar desalination. I mean, sure, it may be possible, but I don't have to do it, do I? It's like there's tons of people that are way smarter than me working on that problem. Also, there's one company I found that's selling desalination gear. They look quite cool.
This is the new Ampac land-based 4,500 gallon per day seawater desalination system. This system is very basic to use, very simple. It also has pre-treatment sufficient for special applications such as a beach well where you have well water mixed with seawater, where you have higher level of iron and manganese, for example, or calcium, magnesium. So the first thing, it has a spin-down filter. The spin-down filter is to remove any suspended solids greater than 50 micron. And then it has an ion exchange system with an automatic valve to backwash and regenerate on time. Then it would have a multimedia activated carbon, catalytic carbon, depend on the application, along with KDF and polyphosphate to treat hard water conditions. Then it has 5 micron sediment filter to remove any suspended solids greater than 5 micron. There is also a feed supply pump in case if the water is settling in a settling tank, it would be able to draw the water from the tank and pressurize all the pre-treatment. Then from there, after the 5 micron, the RO pump will bring the pressure up to about 800 to 900 psi which I think is about 45 bar, if I'm not mistaken. The RO pump will boost the pressure of the water and take it to the membrane elements in the back. The membrane elements will remove salt, and then from there the water is going to go into your permeate or your freshwater settling tank. Once the tank is full, the system is capable of flushing itself. We have filters that draw fresh water, and then from there it goes back into the sediment filter and flush the whole system with fresh water after each use. We also have an ultraviolet lamp at the end of the operation, so ensuring the water is not just pure, salt-free, but also disinfected and sterilized. We have a PLC system that controls the whole operation, the whole skid mount. It will give you water quality, number of hours of operation. Now this is the basic system, it's not the advanced one. We've got more advanced ones with stage DMI and touchscreen PLCs. However, this is just the basic one. So it'll show you the water quality and conductivity or ppm, it'll show you the water temperature, it will show you the number of operating hours. You will also be able to, if anything goes wrong, it will beep and give you an audible alarm as well. Audible and visual alarm, both. There's an indicator light after each phase, so you know exactly what's in operation, what's not. We also have bypass switches for the pumps, just in case if you want to bypass a pump for service reasons. Finally, the last thing on this system is a complete control panel that will really make you in charge of this and in control. There's a pressure gauge after each step, so if there's any clogging for any reason, you'll be able to tell just by looking at the gauges. There's also two flow meters, one flow meter that shows you how much water the system is producing, and it's called the permeate flow meter, and another one to show you how much we're wasting, the drain, the concentrate back to sea. So that way you can see the ratio of how much you're producing versus how much you're wasting. Finally, there is a system pressure control. System pressure control is to adjust the system pressure for getting to reach the best water quality possible. There is also another pressure relief valve on the back of the unit. In case if someone make a mistake and close this valve all the way, it would automatically open so that the pressure won't increase over 900 psi for safety. That's about it. Let's just put this new system in operation so you guys can understand how it works. All I have to do is just push one button, the green button, the power button. Once I do this, the feed pump will start, pressurize the system, then the RO pump will start. By the way, the RO pump also has a variable frequency drive to smooth the operation of the system. Let's push it to start and show you how it works. Level of this unit is not beyond 72 decibel, which is acceptable for human ear, and it's in full operation as it is right now. Thank you.
At first, when I heard that engine, I thought, man, this thing's running on gasoline. But no, I looked at the web page. It's 3-phase electricity. Like, I need a lot of power. But still, it's a doable thing. I could buy one of those machines and get a ton of solar panels and get some seawater and pump it onto some dry land, and then it would be done. And that's a weird thing. You just buy stuff off the web.
It is my father's vision and my father's dream to build this city.
This is an experiment. I mean, it's a very expensive experiment, but nobody's ever done this before.
Normally, engineering and the environment are diametrically opposed. In this particular case, it's the exact opposite. They're very much interdependent. Without the success of one, you won't get the success of the other.
There's a construction revolution in the desert nation of Kuwait. Led by a team of mostly British and Australian engineers, an army of construction workers are creating a new city amid the arid sands, an eco-city designed to bring the life of the sea into the heart of the desert. To build it takes one man's vision, his son's drive, innovative engineering, a committed workforce, and a lot of big machinery. Already it is attracting the attention of the world's leading architects and city planners. For 18 months, our cameras have followed designers, contractors, scientists, and ecologists as they struggle to turn vision into reality. Months of constant pressure and unique engineering challenges.
We knew we were tight, but this has shown that we're actually running quite a lot behind schedule.
If we don't see some marked change within 2 weeks, for example, then we're unlikely to make the program.
If it works, this deserted corner of Kuwait will become a global sensation and change the way we build forever. Welcome to Sea City.
Yeah, I clicked on links on the right side of my YouTube movies. I was doing some research and then I got distracted. Like Sea City in Kuwait, kind of cool, like bringing seawater into the desert is really quite good. Or maybe it's good, I don't know if it's good. I don't know anything, I'm kind of whelmed. The overwhelm has got me.